Tutorial 18. Data Collections Introduction. This tutorial covers two of the most useful objects in the Max world, coll and root. The coll object allows for the indexed collection of data. You can think of it as a small and fast database for message data. The root object is also tied to the concept of indexing. It will send data out of a specific outlet based on the index of a list. Indexed data is very useful for complex routing of information. Often data is already indexed for you. MIDI controllers normally index the value with the controller number, while note information is often indexed by the MIDI channel. Using indexing for data can also help when sending messages throughout a complex patch. By creating an indexing system, you can send data around indiscriminately, and have the root object find and decode the data as necessary. Basic coll handling. There are several small to medium-sized patches scattered throughout the interface for this tutorial. We will be starting with the patch at the top left side. The first patch introduces the coll object. 3 message boxes are connected to it. If you click all 3, you will load the coll object with 3 value sets. The easiest way to see what is stored in the coll is to double-click on it. It will open an editing window that will show you that the first number was stored as an index, and the second number was stored as a value. To programmatically retrieve a value, you send an index value into the inlet. The output will be the value stored at that index location. If you use the number box to send a 0 to the coll object, it will output 20, 1 and 2 will output -50 and 33 respectively. This is the most basic, and most common, use of the coll object as a storage mechanism for indexed value sets. The patch label 2 is slightly different in that it uses symbols, rather than numbers, as the indices. Click on the 3 store message boxes, and again double-click on the coll to see the stored data. The data is similar to the first coll, but the indices are symbols rather than numbers. Now, if you click on the message boxes to the left, the coll object will output the correct value for each of the symbols. The third patch has already stored data in it. If you select any number between 0 and 3, the coll will output the data for that index. In this case, rather than a single number, the coll is storing a string of symbols. All of the symbols are output as a list. Prepending a set message to the list allows us to display the value string in a message box. In order to store the data within the patcher, you have to set an attribute in the coll object's inspector. Unlock the patcher, and open the inspector for the coll in patch 3. You will notice that the attribute labeled Save Data with Patcher is selected. When this attribute is set, any information stored in the coll will be written to the patcher file when it is saved, and is immediately accessible when the patch is opened again. Using coll for drawing and playing. The center section of our patch uses a coll to control both a drawing and a MIDI playback function. In this case, the coll is loaded with some predefined data. However, instead of having been stored in the patcher, this data is loaded from an external file containing data from an EEG readout. The file name is eeg.txt, and that file name is used as the argument for the coll, so the data is read into the coll when it is first initialized. At the top of the patch is a simple little self-incrementing counter system. Each time a number is generated, it increments itself by an amount determined by the upper right number box. By default, the increment is 1, since that is what the plus object contains. Playing through the data set at this speed, however, can take quite a while, as our data file contains many thousands of lines. If you change the number box to 15, you will see the EEG pattern much more clearly. The output of this number generator is used to retrieve the index data from the coll, and is sent to both the drawit subpatcher and a simple MIDI player. The MIDI player just uses the number as the MIDI note, while the drawit subpatcher uses the incoming value as the vertical offset of a scrolling drawn circle. Start the metro and notice how different increment values for the counting change the way the EEG data unfolds. If you need to restart the file at the beginning, the message box labeled 0 will reset the int box to 0 again. Storing data into a coll for later use is the best way to deal with large datasets. This EEG capture, which represents over 18,000 data points, would cause your patcher to be very large if it was stored in the patcher's file. Instead, the data can be captured into a coll, saved in a text file, and read into the coll at runtime. The next patch segment, labeled 5, shows a few more tricks that coll has up its sleeve. This call has a name queues that manages 8 different queues handled by the rest of the patch. You can use the connected number box to fire off the messages, but you can also use the 3 message boxes to walk through the queues. The start message moves you to the beginning of the call contents, while the next and previous messages move forward and backward through the queues. This allows you to step through the call in sequence, even if the entries are not numbered sequentially, and will automatically loop back to the start when the end is reached. This is the easiest way to implement a sequential step-through of a call's contents. Without worrying about the root object just yet, step through the sequence using the start, next, and previous messages and observe how different actions are triggered by the output of the call object. There is also a small patch just to the right, where another call is also named queues. If you double-click on this call, you will see that it has the same contents. In fact, because it is named the same as the previously viewed call, it is actually sharing the contents of the call much like the value object shared data through a naming convention. Using named calls that share their information allows you to have easy access to a dataset in different places in your patch, or even within subpatchers. Message routing with root. The small patch in the lower right shows the functionality of the root object. As you click on the message boxes, the messages are matched based on their identifier. If the identifier matches one of the arguments to the root object, the message is stripped of its identifier, and the remaining data is sent out the outlet. The root object has one outlet for each argument, as well as a final outlet for items that don't match. This patch shows what happens if an unrecognized message is received. The ZEPO message is not enumerated in the root object, and therefore cannot be routed. Rather than ignoring the message, it sends the entire message out the right outlet, possibly to be used by another root object, or perhaps to be sent to the Max console with the print object. Patch segment 5 also uses the root object to take messages from the call and parse them to perform actions on different objects in the patch. As we saw inside the call, the data contains a symbol and a data item. When this message is received by the root object, it uses the first element to determine the output routing, and sends the rest of the message through that outlet. Hence, a message that begins with M1 will be routed through the first outlet, while a message that begins with PIC will be routed through the fourth. If we use the start and next messages to walk through the queue's call, we will see that a sequence of actions is performed based on the first segment of the message. The metro objects are started and stopped, and the random object is triggered twice. You can see that the root object will send tagged message contents where they will be useful. Summary: the call object is a powerful way to work with indexed messages and data. The object provides methods to get specific messages or to step sequentially through the contents. You can share the contents between named call objects, letting you have access to this data throughout your patch. Call can also read its data from external files. We also saw how the root object allows you to track and move messages based on the contents of the message, helping you to route the data that you need to different objects based on an index.